to start topic 6.1, radioactive decay. So 6.1, radioactive decay. So what is radioactive decay? Radioactive decay is a random and spontaneous process where an unstable nucleus becomes more stable by emitting radioactive radiation. The process is random and spontaneous, where it is not influenced by temperature, pressure, and other physical factors. Okay, so this is a very important definition of what is radioactive decay. Random and spontaneous process, where unstable nucleus become more stable by emitting radioactive radiation. Okay, so when you want to explain to people, when question asked, for example, what is radioactive decay? So the keyword that you must have is say that it is a random and spontaneous. These two words must be there. And then you must say that unstable nucleus. You cannot say unstable atom or unstable ion, unstable molecule. It must be unstable nucleus. You say unstable atom wrong. Okay, must be unstable nucleus. Nucleus that are unstable. So the unstable nucleus become more stable. How? By emitting radioactive radiation. So this process is what we call radioactive decay. Okay, the concept of radioactive decay is actually very simple. We have unstable nucleus. So we want to see, okay, and this unstable nucleus want to become stable. So how to become more stable? It depends on the reason why is it that the nucleus is unstable. Okay, you see the reason. Why is it that the nucleus is unstable? So generally, there are two reasons why the nucleus are unstable. First reason is too much mass. That means it is too big. Okay, too big. That means proton, neutron is there's too many proton and neutron. Okay, too many proton and neutron. Okay, and then okay, either too much mass and cause the and sometimes because the how you say the ratio between the proton and the neutron is incorrect lah. It's not right. So it makes the nucleus become unstable. Okay. Okay. But generally, you can say that it's too much mass because generally a big nucleus is unstable lah. Usually for the nucleus that is too big, very big and it's unstable. Okay. Another reason is too much energy. Okay, then it becomes unstable. So, how to become stable? Too much mass, throw away the mass. I have to go on diet, throw away the mass. Throw away the mass, then it will become more stable. So that means, what are the mass? What are the source of the mass of the nucleus? proton and neutron, right? Proton. So throw away some of the proton and neutron inside. Okay. Throw away some of the proton and neutron inside. Then the mass can be increased and it will be able to become more stable. If too much energy, then throw away the energy. Release some of the energy, then the energy level will increase and the unstable nucleus become more stable. Okay, that's simple. Okay, so this energy and the proton and neutron or some other mass, they are released or emitted by the unstable nucleus. We call them radiation, or we call them radioactive radiation. Okay, call them radioactive radiation. Why is it that we call them radioactive radiation? Because these radiation are emitted in the process of radioactive decay. So this process is radioactive. So the radiation that are emitted during radioactive decay, we call them radioactive radiation. Okay? For your information, there are a lot of other kind of radiation. For example, electromagnetic wave, we also call them radiation. Okay? Electromagnetic waves are also radiation. So, for example, radio wave also considered radiation. Microwave also considered as radiation. Infrared, visible light, for your example, for your information, visible light, the light that we can see, are also radiation. So, the microwave, the X-ray, gamma ray, all of them are also radioactive radiation. Okay? Alright. Okay. Now, let's look at the meaning of random and spontaneous. Okay? What does it mean by random? For example, in mathematics, when you learn about probability, the situation is always where there's a box. Inside the box, there are many balls with different color. You have a red color ball, you have a blue color ball, you have a yellow color ball, green color ball. Okay, a lot of different color ball. So you put your hand into the box without looking, and then you randomly take one ball out. So that means, what does this mean? This means the meaning of the word random is you don't know which one you will get. You don't know which ball you will get. You don't know which color right now. Maybe you get red color ball. Maybe you get red. Okay? Maybe you get purple. Okay? Don't know. You don't know what color of the ball that you are going to get. So in this case, the meaning of random in radioactive decay is, let's say that in an object, in this object there are many atoms. Many atoms. Okay, billions and billions and billions and billions and billions of atoms. So out of all of those atoms, let's say that there are many of them have unstable nucleus. Okay, many of them are unstable nucleus. Okay, So the process of radioactive decay is random, meaning we don't know which of these nucleus will decay. We don't know which of the unstable nucleus will decay. There are no indication. There are no sign that will tell us that next this one will decay. So, okay, there's no way to know which nucleus, which unstable nucleus is going to decay. Okay, so that is what we call random. Okay. Don't know which they don't know which unstable nucleus. How about spontaneous? Spontaneous have something to do with time. That means we don't know when is it going to decay. Don't know when. You don't know when it depends. The unstable nucleus will decay and is reduced. So that means it can be any of them. We don't know which one, and we also don't know when is it that's going to decay. Nothing can affect the decay process. Nothing can affect the radioactive decay, the process of radioactive decay. It is totally random and spontaneous. That means if you hit it, if you hit with a hammer, bang, 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 hit with hammer, it will not make more of the unstable nucleus decay. You increase the temperature, you heat it, put in the fire, you heat it. Also, it will not make the process become faster. It will not make more of the unstable nucleus decay. Okay, and increase the pressure. You put it under high pressure. Go put it in space. Go temperature. Whatever you do, it will not be able to control the decay process. Okay, so it's totally random and spontaneous. So that is why here we say not influenced by temperature, pressure, and other physical factors. Okay, you understand that? Okay, so this is radioactive decay. So just now we discussed that radioactive decay is the process where the unstable nucleus become more stable. So the process of the radioactive decay can be grouped in, we can define three different types of decay. The first is what we call the alpha decay. Okay, we call the alpha decay. So you can see that the alpha symbol here. So that means when you answer question, it is not necessary for you to write the word alpha. So you can write the symbol alpha and then you write decay also can. Okay, you can use the symbol alpha to represent the word alpha. Okay. So alpha decay is where an unstable nucleus releases an alpha particle to become a more stable nucleus of a new element. Alpha particle is consists of 2 protons and 2 neutrons, which we call a helium nucleus. So basically what happens is this parent nucleus, this is unstable. This unstable nucleus, it decay and release alpha particle. This alpha particle is a particle that is consists of 2 protons and 2 neutrons. Okay, and then it decay and then shoot out the particle that is consists of 2 protons. So this particle of 2 protons, 2 neutrons, we call alpha particle. Okay, get the idea. And because the alpha particle, the component, the component of the alpha particle, which is 2 proton, 2 neutron, because it is the same as the nucleus of helium, so we also call it as helium nucleus. Understand? I must stress that the alpha decay do not release helium nucleus. It's not at all. It purposely release helium nucleus, not like that. This decay process, it shoot out, it emits a particle that is consists of 2 proton, 2 neutron. Okay, it has nothing to do whether that it is a helium nucleus or the nucleus of any other element. Okay, this decay process, alpha decay, emits a particle that has 2 proton, 2 neutron. So we call it alpha particle. And because this 2 proton, 2 neutron is the same as the nucleus of helium, so we also call it helium nucleus. Okay, so that means we do not have other kind of decay that emit oxygen nucleus, emit boron nucleus, emit carbon nucleus, sodium nucleus. Don't have, don't have. Okay, understand? Please do not misunderstand. I stress this because in the past there are quite a number of students that have this kind of misconception. They thought that this alpha decay can emit helium nucleus. So maybe other kind of decay process, other kind of there must be other kind of decay process that emit nucleus of different elements. Yeah, no, not like that. Okay. So when the so you can see here, when the alpha particle is emitted, then the mass of the unstable nucleus decrease and it becomes more stable. Okay, it becomes more stable. It does not necessarily it straight away becomes stable. It becomes more stable because the mass is increased on it. Okay, so the product we call the daughter nucleus. And this daughter nucleus is a different element. It's a new element. That means the element changes. From the parent nucleus, the parent nucleus element and the daughter nucleus element are 2 different elements. Why? Because when it emits the alpha particle, proton also emitted. Okay, proton, it emits 2 protons inside the helium nucleus. So that means the number of protons of the nucleus changes right now. And we know from periodic table, look at the periodic table. Okay, number 1 is hydrogen. Why number 1 is hydrogen? Because hydrogen has 1 proton. So any atom that has only 1 proton is hydrogen atom. Okay, hydrogen atom. And then if number 2 is what? Number 2 is helium. Right now, number 2 is helium. Why number 2 is helium? Because helium have 2 protons. 2 protons. So any atom or any nucleus that have 2 protons belong to the helium element. Okay, belong to this. We call it helium. Okay, the element helium. So you see, what element is the atom? Okay, the atom is atom of what element? Depend on the proton number. Right? Depend on the proton number. So if the number of protons changes, so that means the element also changes. Right now, okay, the element also changes. Yeah. So that is why when the unstable nucleus undergo alpha decay, it could change into a new element, a different element. Okay. So the general equation of alpha decay is like this. So this X is the symbol of the element, okay, or the chemical symbol lah. Okay, the chemical symbol. This A is what? This A is the sorry. This A is the neutral number. This Z is what? This Z is the proton number lah. Okay, this Z is the proton number. Okay, so this is something that you learn in chemistry lah. Okay, chemistry. Okay, so you see when this element X, when it undergo alpha decay, it will emit alpha particle. So you see the symbol that we use to represent alpha particle is helium, the symbol for helium. The reason is because the component of the alpha particle is the same as the nucleus of the helium. So that is why we use the symbol of helium. Remember, this is the helium nucleus. If you say that it emits helium atoms, then it's wrong. Helium atom is wrong because it's just the nucleus. It's not the whole atom. Okay, it's just the nucleus. This is very important. Okay, so because it emits the 2 proton, so that means the proton number minus 2. This proton nucleus is Y. Okay, from X element change to Y element, so the proton number minus 2. The neutron number minus 4. Because neutron number is total number of proton plus total number of neutron. Okay, that is something that you already learned. Okay, so neutron number minus 4, proton number minus 2. Okay, so let's look at an example. For example, we have this polonium. Okay, and after the polonium undergo alpha decay, and then it will emit helium nucleus or alpha particle. Okay, so what happened is this from polonium it will change into lead number, lead. So the proton number 84 minus 2 become 80. So that means the proton number 82, that means it is the element of lead. And then the neutron number minus 4, so it becomes 206. Okay, like that. Next, this is this is thorium. Thorium. So thorium undergo alpha decay and it becomes this is radium. Radium. Okay, so it means helium nucleus. So the proton number 90 minus 2 it becomes 80. And then the neutron number becomes 226. Okay, so you see 88 plus 2, 88 proton plus 2 proton is 90 proton. 226 neutron number plus 4 neutron number. Okay, so you see, same like in chemical equation also, the left side of the chemical equation say equal to the right side, so we balance up. Okay, but in this case we balance the component in the nucleus. Okay, the number of the proton, the number of the proton. Okay, so this U is the uranium. So after undergo alpha decay, become thorium. Okay, it becomes thorium. So 92 becomes 90, 238 becomes 234. Okay. Okay. Continue. Okay, so just now is alpha decay. So now we want to look at beta decay. So what is beta decay? Beta decay is where a neutron in an unstable nucleus decomposed into one proton and one electron to become a more stable nucleus of a big element. So the resulting proton remains in the nucleus while the electron is emitted with high kinetic energy. So beta particle is a fast moving electron. So what happened here is the parent nucleus, this is unstable nucleus, okay, undergo beta decay. So when undergo beta decay, what happens is one of the neutron, one of the neutron break down and change into one proton and one electron. So now to understand why we think the neutron is neutron, because inside has both the charge positive and charge negative. So so when the neutron decay, the neutron breakdown, sorry. So when one of the neutron breakdown to become one proton and one electron, the new proton from the neutron stay in the nucleus, and the new electron shoot out with high velocity. That means because it has a high kinetic energy. Okay? So this proton that shoot out, we call it beta particle. So this beta particle and the alpha particle, they are radioactive radiation. Okay, the beta particle that fly out, alpha particle that fly out, they are radioactive radiation. Okay. So let's look at the general equation. Say this X is the chemical symbol. So from X element change to Y element. Why? Because the number of proton change. See the number of protons increased by 1. Because the neutron breakdown change to proton and electron. So the number of protons increased by 1. And then the electron fly out. So the symbol for electron is a small e. And then the neutron number is 0 because it doesn't have any proton. No proton, no neutron. So it's 0 number. And then the proton number is -1. Why proton number -1? Because the electron is like the opposite of proton. Right now, proton is 1. So electron is the opposite of proton. So we put -1. So the element Y, the proton number is Z plus 1. So you can see that this Z plus 1 is plus -1, then it becomes Z. See or not? So this is the general equation of beta decay. So the left side and the right side they are. Okay, next. Let's look at the example. So we have sodium. Okay, sodium. So this sodium 24 is undergo beta decay and turn into magnesium and release one electron. Okay, this electron is a beta particle. So the number of protons increased by 1. So 11 becomes 12. So the neutron number, any changes or not? Neutron number, no change. Okay? Why neutron number no change? Because one neutron break down. So you minus one neutron, but you plus one proton. So -1 plus 1, the number remains the same. Okay? So next is carbon 14. Carbon undergo beta decay, emit beta particle, and then carbon, the carbon change into nitrogen. So 6 becomes 7, 14, 14. Okay, what numbers? Next, lead, number lead, 209, undergo beta decay, become bismuth. So 82 become 83, total number 209, total number still the same. Okay, so very simple. Okay, after this, we have the third and the last type of radioactive decay, which is the gamma decay. Gamma decay is when an unstable nucleus release excess energy, too much energy, so throw away the energy and then become more stable. So the energy is released as gamma ray. That means the gamma ray, the electromagnetic wave, it carry the energy away. So gamma ray are high frequency electromagnetic wave, so it has no mass and no charge. So the nucleus becomes less energetic after gamma decay, become more polar. So you can see here radioactive nucleus in an excited state undergo gamma decay, so it becomes nucleus with less energy and release gamma ray. Okay, so general equation. So you see the element is still the same. X element is after undergo gamma decay is still X element. Okay, there is no change. Okay, still the same X element. And with this gamma ray. So this the symbol for the gamma ray is a symbol of gamma. Okay, it's how you write the symbol gamma. Okay, this is alpha, beta. Okay. So during, let's do an example. So the cobalt, for example, cobalt 60, undergo gamma decay, emit gamma ray, and still it is cobalt. Proton number 27, neutron number 60. Okay? Sorry. Okay, sorry. Okay. So during radioactive decay, some nuclei can emit more than one radiation. So for example, okay, so this uranium, it undergo alpha decay and gamma decay together. So what happens is the uranium becomes thorium. Okay, become thorium. So you see 92 become 90. Okay, and then 234 become 230. So at the same time, it undergo alpha decay and gamma decay. Okay, so this decay equation, okay, this decay equation, we can write as a more simpler version. That is like this. So uranium become thorium. Okay, after undergo alpha and gamma like that. So we just write the two symbol alpha gamma here. So we don't need to write this symbol for the alpha particle. Okay, we just write like this. Also can. Okay, good idea. All right. So let's look at example. Okay, number 1A. Identify P and Q in the equation below. So one is P, one is Q. So obviously, see, P have 2 proton, 4 neutron number. So P is obviously helium. Yes, you cannot say that P is helium. Okay, you cannot say P is helium because if you say P is helium, it is like you are saying that it is a helium atom. So you say P is helium nucleus. Okay, and then Q is electron. Q is gamma ray. Okay, gamma ray. Okay, and then the nucleus, uranium-238, decayed by emitting an alpha particle. The resulting nucleus decay further by emitting a beta particle, producing a daughter nucleus Y. What is the symbol of Y? Okay, so when you say what is the symbol of Y, it doesn't mean that we want you to identify what is the element. We just want you to write the symbol like this. Okay, so Y. Okay, so first we look at the number of protons. You see, 92. After emit alpha particle, then that means it will minus 2 of the proton. Okay, proton number minus 2. And then after that, it says that it decays further by emitting beta particle. That means the number of protons increased by 1. So 92 minus 2 plus 1. So it becomes 91. So this is the proton number of daughter nucleus Y. Okay, how about the neutron number? Neutron number 238 after undergo alpha particle, after undergo alpha decay, 238 becomes 234. Okay, cos minus 4. So 238 becomes 234. And then when undergo beta decay, neutron number does not change. Right now, does not change. So it is still 234. Okay, okay, so this is the symbol for Y. Okay, next see. How many beta particles are emitted when Sp is medium? Okay, decay into cesium. Okay. Okay, so how many beta particles are emitted? So you see that 51 become 55. So, 51, 131 become 55. This is also 131. Because beta decay doesn't change the neutron number. Okay, how many beta particles? Okay, how many beta particles? So you see, 51, 55. So that means this 51 must plus 4 become 55. So 55 must minus 4 lah. Okay. So this number of beta particle must be 4. Okay, 4 beta particle. See or not? 55 plus negative 4 becomes 51. Okay, so 131, 131 plus 0, same as 131. Okay, so how many beta particle? 4 beta particle lah. Like that. So this is one way that you can give the answer. Or it depends on how many marks are. For example, if it says 2 marks, then you show this. If it's 1 mark only, then you can straight away say that 4 beta particle. You don't have to write this whole thing. You say 4 beta particle. If the question is 1 mark only. Okay. So, have you here any question? Anybody have any question here? Okay, no question. Thank you very much for this opinion. Thank you very much. Okay, so the next part, okay, the next part is half-life. Okay, but we do not have a lot of time. Okay, so half-life we will discuss later lah. Okay, we will discuss in tomorrow. Okay, half-life we will discuss half-life. So today we stop here lah. Alright, today we stop.